Okay, we're on problem 24. So in problem 24, we're going to use either the substitution method or the elimination method to solve each system. Okay, so I'm using the substitution method on this first one and then the elimination method on the second one. Again, the elimination method is the same thing as the addition method. So, all right, in the first one, I like the -1 in front of x there. So with the substitution method, like I'm going to pick an equation and pick a variable and solve for that. Let's solve the second equation there for x. So if I add x and then subtract 8, x is equal to 6y minus 8. Okay, and then we're going to go ahead and substitute x into the top equation where we see x. So we got 3 times 6y minus 8 minus 2y equals 4. Or that's going to be 18y minus 24 minus 2y equals 4. 18y minus 2y is 16y. When I add 24 to both sides, I got 28 on the right. So then divide by 16. 28 over 16 reduces. A 4 goes into those two numbers evenly. So 7/4 will be the value of y. And then to get the x value, we'll go ahead and plug 7/4 into the substitution equation. So I got 6 times 7/4 minus 8. 6 over 4 is 3 over 2. And 3 times 21 is, or 3 times 7 is 21. So I'm looking at 21 halves minus 8. 8 is the same thing as 16 over 2. So then that's going to give me 5 over 2 as the answer. Okay. Now, something I mentioned in the last video is the kind of the benefit of using the substitution or addition method, rather than using the graphing method. So like, I'm not sure if this would be an easy point to see on a graph. Okay, so like we'd probably want to use either the substitution method or the addition method to solve. Okay, and of course I can check this, right? So I check the answers. So let's see, if I plug that back in the system, I have 15 halves minus 14 over 2. 14 over 2, that's the same as 7 halves. 15 halves minus 7 halves, that's 8 halves. Or 8 over 2, that's 4. That's good. Okay, and then in the bottom equation, let's see, I got -5 halves plus 6 times 7 over 4. That's the same thing as 21 halves. Okay, so I got -5 halves plus 21 halves. That's 16 halves, or 16 divided by 2 is 8. Okay, so that's good. That'd be the answer. Part B is where we're solving this system. So I'm going to use the elimination method or the addition method to solve this system here. And let's plan to eliminate x. Okay, so to make that happen, we'll multiply the top equation by 4 on both sides and the bottom equation by 6 on both sides. And then that way when we add these together, we'll get rid of x. So let's see, I'm looking at 24x minus 24x, that's 0. And then -60y plus 60y, that's 0. Okay, 4 times 12 is 48. Minus 48, that's 0. Okay, so I get 0 equals 0. Now, it's not news to me that 0 equals itself, right? Like, I already know that. But this is different from this example right here, right? Because 0 is not equal to -4, right? So that'd be an inconsistent system. Here we've got a dependent system. Now, a dependent system just means that you've got a line on top of a line. And so this is essentially the same line, just drawn twice. Okay, so my answer is wherever the lines intersect each other. Well, if it's the same line drawn twice, then these two lines are going to intersect infinitely many times, right? So there's going to be infinitely many answers to that. Now, the answer has to be written as an ordered pair. Okay, x, y, where everything is either in terms of x or everything is in terms of y. So I'm going to go ahead and write everything in terms of x. So I got x, y is the same thing as if I solve this bottom equation here for y, then I got negative 4x plus 10y equals negative 8. Solve that for y, so let's add 4x and then divide by 10. 4 over 10, that's the same as 2/5. So I got 2/5 x minus 8 over 10, that's the same as 4/5. So in the y-coordinate spot there, I'm going to go ahead and plug in 2/5 x minus 4/5. Okay, and this would be my answer. Now, this is one way to describe how there's infinitely many solutions to this system. You know, because you can give me any value for x that you want to get started with the problem, and I can always find a corresponding y value by taking 2/5 times that number minus 4/5. So, but the point is that you can give me any number there to get started with the problem. So that's why there's going to be infinitely many numbers that would be solutions to this system. Okay. Let's try problem 25. So there's a couple of applications here. In problem 25, it says adults are charged $6 and children are charged $4 to see a play. Last night, 103 people saw a play, paying a total of $532. How many adults and how many children were at the play? Okay, I'm going to let X be the number of adults that were at the play and Y be the number of children that were at the play. And I've got to come up with a system, you know, representing what's going on there. Okay, so the first one is, so they told me that 103 people saw the play. Okay, so if I take the number of adults and then add the number of children, I get 103. That'd be one equation there that I write down. Another equation would be the cost equation. So it costs $6 for adults and $4 for children. And the total cost for the night was $532. Right, so I got $6 for an adult plus $4 for a child, and I get $532 total. That'd be my second equation. Okay, and let's see. So to solve this, I guess I can use you know, whatever method I want. I'd say, you know, avoid using the graphing method. Okay, just because we have no idea what these answers are going to look like. So I'm going to use the substitution method here for this one. And if we solve the top equation for y is equal to negative x plus 103. And let's go ahead and substitute y into the bottom equation where we see y, so that way everything is in terms of x. We'll have 6x plus 4y is the same thing as negative x plus 103, and that's equal to 532. Okay, when you solve that for x, we got 6x minus 4x plus 103 times 4, that'd be 412, equals 532. 6x minus 4x, that's 2x, and when I subtract 412 from both sides, 532 minus 412 is 120. Okay, and then if you divide both sides by 2, x is 60. Okay, so it looks like 60 adults were at the play last night, and to find the number of children, let's go ahead and plug x equals 60 into this guy here. So we got negative 60 plus 103, there'd be 43 children that were at the play. Okay, so I'd circle that, the answer there. Okay. Problem 26 is the next one here. So now we're going to focus on 3x3 systems. Okay. And so what I mean by that is, you know, 3 variables, x, y, and z, and where you got 3 equations and you're solving. Okay. Now there's a method that we'll talk about later on in the next video. That's going to be kind of the preferred method for solving a 3x3 system or bigger. In section 5.2, your book kind of focuses on using the addition method repeatedly. Okay, so I'm going to use that method here for this problem. Let's eliminate x by using the first and second equations. And let's also eliminate x by using the first and third equations. Okay, that way we'll reduce this down to a 2x2 system, which we've been solving 2x2s, you know, and I can continue the problem then using this 2x2. Again, I'm going to eliminate x by using the first two equations, and then eliminate x by using the first equation and the third equation. So with the top equation there, if I multiply by -5 on both sides, and then add those equations together, let's see, I got -5x plus 5x, that's 0. And then -15y minus 6y is -21y. 5z plus z is 6z. Okay, and then let's see, I got -30 plus 5, that's -25. Okay, so that'd be one equation here. Now, I'm also going to eliminate x by using the first and the third equations. Okay, so to make that happen, let's multiply the top equation there by -2 on both sides. So then when we add these together, x is gone. We have -2x plus 2x, that's 0. Okay, and then -6y minus 3y is -9y. 2z plus 4z is 6z. And then -12 minus 9 is -21. Okay, so my second equation here would be -9y plus 6z equals -21. And these would be the two resulting equations from eliminating x. Okay, now the next thing, if I go ahead and subtract these equations, then z will be gone. Okay, let's do that. Let's use the addition method again. And I'm going to go ahead and subtract these equations. So I got -21y minus -9y. That'd be -12y. 6z minus 6z is 0. Okay, and then -25 plus 21, that's -4. When you divide by -12, y is 1/3. Okay, so knowing y is 1/3 means that we can get z by, let's use this equation here, and we'll get z. So if y is 1/3, I got -9 times 1/3, that's -3, plus 6z equals -21. When you add 3 to both sides, 6z equals -18, divide by 6, so z is -3. Okay, so we know y is 1/3, z is -3, and then to get x, I'll go ahead and plug those two numbers into the top equation there on the original system. So I got x plus 3 times y is 1/3 minus z is -3. Okay, so that's going to be x plus 1 plus 3, 1 plus 3 is 4, equals 6. When we subtract 4 from both sides, it looks like x is 2, y is 1/3, and z is -3. Okay, let's go ahead and check that. Okay, so is it true that 2 plus 1 is 3, minus a -3, that's 6. Okay, that's good. And the second equation here, we got 10 minus 2 is 8. Minus 3 is 5. That looks good. And with the third equation, we have 4 minus 1 is 3. Minus 12 is negative 9. That looks good. Okay, so I can go ahead and circle this, this answer here. That'd be correct. Okay. We'll start section 5.4 then, which is the last section in the course. I'll show you some problems with that, starting with problem 27 here. We'll do that in the next video.